I am George. Welcome to my presentation. In this presentation, I'm going to talk about a development model that pretty much influenced the way we create software nowadays. It is the first waterfall ever known, even before Winston Roy's famous paper on the waterfall model. For those of you who don't know what a development lifecycle model is, an SDLC model describes the types of activity performed at each stage in a software development project and how the activities relate to one another logically and chronologically. What you see on the left-hand side is Sage model, which is a sequential model. A sequential model means that the development activities are completed one after another. So how it all started. The intelligence sources in the US reported that scientists in the Soviet Union were pushing hard to develop a nuclear capability. President Harry Truman announced in 1949 that the Soviets tested their nuclear bomb. Not only they had the bomb, but they have also developed long-range aircraft able to reach the US via an Arctic route. At that time, the US had no defense against a nuclear attack. Department of Defense assigned U.S. Air Force the task of improving the nation's air defense system, but in turn, the Air Force asked MIT for assistance. This led to the formation of MIT Lincoln Laboratory. This became the most ambitious information processing project of the 1950s, the development of the semi-automated ground environment for US and Canadian air defense. It brought together leading radar communications, computer, and NASA software engineers to develop a system that would detect, track, and prevent enemy aircraft from bombing the US and Canadian homelands. The Sage digital computer should be able to receive vast quantities of data from multiple radars and perform real-time processing to produce targeting information for intercepting aircraft and missiles. Sage Data Combat Center was deployed in New York, close to the North Atlantic Ocean and Canadian borders. The building was made up of four levels over 3.5 acres. Now, what you see on this slide are the Sage computer frames. The computer was designed by joint Lincoln Laboratory and IBM committees that managed to merge the best elements of their members' diverse backgrounds to produce a result that advanced the state of the art in many directions. AN FSQ7 was the heart of the Sage system. Each computer weighted 250 tons, had a 3,000 kilowatt power supply and required 49,000 vacuum tubes. To ensure continuous operation, each computer was duplexed. It consisted of two machines. The building had 24 of those machines. Now, here are just some specs, but it's just for your understanding of how devices have evolved since those times. And you can see that your phone nowadays is a million times faster than a 250 tons machine. The scope of Sage Air Defense System, as it evolved from its inception to its full deployment, was enormous. The cost of the project, both in funding and the number of military, civilian, and contractor personnel involved, uh, exceeded that of the Manhattan Project. Now, this is one of the reasons that Agile appeared in the 19s. The waterfall model and those monolithic projects costs were enormous. This machine used Punchcards to load its data. For those who don't know what a punch card is, you can see it here on this slide. The person who is operating this IBM machine, what he basically does there is inserts the cards inside, and once he starts typing on that keyboard, the machine will literally punch the cards inside the machine, making holes in it. Now, imagine you had hundreds of those cards for your machine, but if you ever have the misfortune of accidentally dropping your program on the floor, it could take you hours, days, or even weeks to put the code back in into the right order. Well, there was a trick, a common trick that was used there back then was to draw a diagonal line on the side of the car stack called striping, so you'd have at least some clue on how to get it back into the right order. Sage development model came into the discussion at the symposium on advanced programming for digital computers. It was Mellon who was deeply concerned with the programming of Sage. He probably wanted to have some feedback from that, but in essence, it was Bennington's paper that was presented at that symposium that included this model. But what you see on this slide is Dr. Bennington, who worked on developing the prototype software for the Sage system. The paper was later republished by Bennington, who pointed out that the process was not performed in a strict top-down fashion, but depended on a prototype. As far as I can tell, the prototype concept was used in Bohm's spiral model. The spiral model is using a risk-based approach where you keep refining your requirements based on feedback. Since many times are the requirements that can bring failure into your waterfall approach. Once you get deeper into the phases, it gets more costly to change things. In in the 70s, a software engineer named Dr. Winston Royce wrote a seminal paper entitled Managing the Development of Large Software Systems. In this paper, he recommends that if the program is being developed for the first time, then you have to create a prototype first. So it's basically the same idea with Sage, that they created an experimental prototype before the actual programming. In Bennington's republished paper, the editor's uh, notes out four important points. Uh, uh, Number one, they have written a lot of software for experimental purposes. My best guess is that it kind of confirms what Bennington just said, that they created an experimental prototype. The second and third points are basically going toward the flow that the waterfall has when creating large computer software. Um, Third is that people did not learn from Sage mistakes, which is what Winston also tried to show to people in the 17s with his straw model. Now let's talk about the model itself. As you can see here, I created two versions of it. On the left hand side is the original view of the model. Here you can see the testing activities start right after the coding stage. The basis for these testing activities are the arrows in blue. To differentiate the other activities from the testing, I call them development activities. The problem with this model is simplified and is also simplified in Winston's paper, where he described a flow of the waterfall. He pointed out that testing starts late in the development lifecycle, right after the coding stage. The V model was first published by the Starts Guide in the 80s. What is interesting is that if one arranges the steps in a V form with coding at the bottom, like on the right hand side, this 50s process is equivalent to the V model for the software development. I hope you find this presentation useful. Um, I'll put the links to the papers that I used for this presentation in the description below. Well, so thank you for watching, and I'll see you next time.